Okay, so I just want to go through your homework and answer all the questions with you in case you got stuck on anything, okay? Feel free to fast forward or rewind as you need. So on number one, we're trying to find f of 10. That means the x value is 10, so we have to look for where the domain includes 10. That's going to be when x is greater than or equal to 5, okay? So that means I'm going to be plugging 10 into this equation right here. 3 times 10 plus 2, which would mean f of 10 is going to be equal to 32. Okay? F of 0, well, that's going to be when x is less than 5. 0 is less than 5. So I'm going to substitute that into 3/4 times 0 minus 1, which is just negative 1. Okay? For f of 5 is when it's equal to 5. So there's my or equal to. So I'm going to be substituting it into 3 times 5 plus 2. 3 times 5 is 15, plus 2 is 17. And then finally, when f is doing f of negative 4, when x is equal to negative 4, that's when x is less than 5. So I would be substituting it into 3/4 x minus 1. So 3/4 times negative 4 minus 1. 3/4 times negative 4 is negative 3, minus 1 is negative 4. Okay, for the next one, f of negative 6. So I want to see where is negative 6 in the domain. Well, negative 6 is less than or equal to negative 3, so I'm going to be substituting it into 2/3 x plus 2. Okay, so that would be 2/3 times negative 6 plus 2. 2/3 times negative 6, that would be negative 4 plus 2, or negative 2. For f of 3, where is it equal to 3? That's going to be when it's greater than or equal to 1. So I'm going to have to do 3 cubed, which is 3 times 3, which is 9, times 3 is 27. F of negative 2, negative 2 is in the domain between negative 3 and 1, and no matter what, f of x is equal to 2 in that domain. And then finally, f of 1. Well, 1 is not going to be here because this one does not say or equal to. I would have to do x cubed. So that means I'm going to do 1 cubed. 1 times 1 is 1, times 1 is 1. Okay, on this one, you can see I started to go over it in class a little bit, but what we're going to do here is solve for all the values that they gave us up here. And when we write our answer, we just need to make sure we're writing them in function notation. So f of 3, we need to look at where 3 is in the domain. Well, I know that 3 is between 1 and 4, so I'm going to have to use a negative x squared. So I have negative and then 3 squared. 3 squared is 9, so it'll be negative 9. Okay, the next one I'm solving is f of 6. F of 6, the domain is going to be when x is greater than 4 because 6 is greater than 4. So it looks like I'm going to have to do 0 times x plus 6. So 0 times 6 is 0, plus 6 is equal to 6. My next one, f of negative 1.5. Well, that's when, let's see, x is negative, so it has to be when x is less than negative 1. So I'm going to plug it into this equation here. 2 times negative 1.5 minus 4. 2 times negative 1.5 is negative 3. Negative 3 minus 4 is negative 7. Okay, then finally, f of 4. So we want to substitute 4 in, and it looks like we have an or equal to here. So we're going to use negative x squared. So it's going to be negative and then 4 squared. 4 squared is 16. And then it's negative, so it would be negative 16. That's how you evaluate each part. Now, for graphing the piecewise functions, this is where my trick was. I told you graph the whole thing and then erase. Okay? So the first function I'm going to graph is 1/2 x minus 1. Here I can see my y-intercept is -1, so I'm going to put a dot there. And my slope is 1/2, which means I'm going to rise 1 and run 2. So I'll go up 1 over 1, 2. And I'm just going to graph the whole thing across the entire graph. Whoops. And then I'll take into consideration the domain. Down 1 over 2, down 1 over 2, down 1 over 2. So this is my line. Okay, now I'll look at the domain. The domain is when x is greater than 4. So I'm going to count 1, 2, 3, 4. So everything that's greater than this value. It's not equal to though, so I'm going to have an open circle and it's going to go anything to the right of that because it's greater than. And then I can erase everything else. Erase this part and these dots, and then I just have an open circle right there. Okay? Now the next part of my line is going to be -2x plus 3. The plus 3 tells me that my y-intercept is 3. The -2 tells me I have a slope of -2. So I'm going to go down 2, and then I'm going to go to the right 1 because I want this to be a descending line. Okay, and then I'll go ahead and continue that pattern. Okay, I'll go ahead and connect the dots so I can see my entire line, and now I'll look at this domain. X is less than or equal to 4. So here's where x is 4, and if it's less than that, I want everything to the left of that. So here's my line, and I want everything to the left of it. Even though it's going up, this is still the part that I want to keep right here. Okay, because it's going to the left, it's where x is less than 4. Everything else, I'll just erase. Okay, and that would be my piecewise function. Okay, on the next one, I'm going to do the first part, 2x minus 5. My y-intercept is 0, -5. Put a dot there. And my slope is 2. So I'm going to rise 2 and go up 1. 2 over 1, 2 over 1, 2 over 1, and so on. Okay? Again, I'll go ahead and create my line there. I'm sorry it's not perfectly straight. And my domain is when x is greater than 1. So here's 1, and I want anything bigger than it, but not equal to. That means I'm going to have to do an open circle. And anything bigger than it. So it's going to be anything to the right side. Just going to make my line nice and thick. And then that means I'm going to get to erase everything else. And I'll even erase that little dot inside because I know it's going to be an open circle right here. Okay, now the next one is 4x minus 3. Here my y-intercept is down at -3. Put that right next to it. And my slope is 4. So I'm going to go up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. Or I can go down 4 over 1. Okay? So I can kind of connect my lines there. I didn't do a great job. Okay? And then it says my domain is when x is less than or equal to 1. So I look for 1, here's 1, less than or equal to, so it's a closed circle. And if it's less than, it's anything below. And then that means I get to erase anything else. So I'm going to go ahead and erase this and that. That would be my graph. Now, I can also check. Remember, this whole lesson is about linear functions. So I can make sure that this is a function by doing the vertical line test, okay? If I did the vertical line test here, notice it only goes through one time. If I do it here, it's only going through the green line, only through the green line. Here, It's only going through the red line. So I know, in fact, that this is a function. Okay? All right. Next one here, we have 2x plus 3. My y-intercept is 3, and my slope is 2. Okay? And I'm going to connect the dots just like I normally do. And then my domain is x is greater than or equal to 3. Negative 3. So I look for negative 3. 1, 2, 3. It's greater than negative 3. So here's where it's negative 3. And it's anything bigger than that. So anything going to the right. So it's everything above negative 3. That means that I'm actually able to erase anything below. Okay, so that's my first line. And my second line, negative 1/3 x plus 1. So I'm going to make my y-intercept at 0, 1. And my slope is negative 1/3. So I can go down 1 and to the right 3. And down 1 and to the right 3. Or I can go up 1 and to the left 3. Okay. Now, I could draw my line through this, and I can kind of already see that there's going to be a little bit of an issue because my lines are intersecting, and I haven't had that with piecewise. Because if that happens, that kind of just means that there's no solution. Okay, so let's see what's going to happen here. Or, sorry, that it wouldn't be a function. X is less than negative 3. So here's negative 3, and I want anything less than that. Less than that means that it's all the numbers smaller. So it's anything to the left. So that means I can be here, but it's not going to be equal to. So I'm going to go ahead and do, an open circle there, and it's anything bigger than that. Okay? So it'll be like this. And then I can go ahead and erase everything else. So it's nothing to the right. Again, I can do the vertical line test to check to make sure it's a function, because that would mean that every input only has one output. All right. On this next one, 3x plus 4 is what I start with. So 3x plus 4, this one's a little hard to see. My y-intercept is 4. And my slope is 3. So I'm going to go up 1, 2, 3, and over 1. Up 1, 2, 3, over 1. Up 1, 2, 3, over 1. Or I can go down 1, 2, 3 to the left 1, 1, 2, 3 to the left 1. Okay? So that's my line, and then the domain is when x is greater than or equal to 1. Here's 1. So greater than or equal to is going to be this part right here. It's or equal to, so that's a closed circle. Okay, and then everything below I can get rid of. On the next one, I have x plus 3. So my y-intercept is 3, and my slope is just positive 1. So I just know it's going to go up 1 and over 1 each time. So I'm just going to go ahead and draw my line. My domain is when x is less than 1. So here's 1. It's less than, so it's going to be an open circle, and it's anything below that, okay? So I'm going to draw my nice big bold line, and I'm going to make it less than that. Everything else I can erase. Okay? All right. Next one, we have 1/3 x plus 1. My y-intercept is 0, 1. My slope is 1/3, so I can go up 1 over 3 or down 1 into the left 3. And that'll help me create my line here. And then x is greater than 3. 1, 2, 3. So anything greater than 3. It's not equal to, though. So I'm going to actually go ahead and erase that little dot, and I'm going to make it an open circle and anything bigger. So it's going to be anything to the right. Everything else I can erase. Okay. Next one, f of x equals 4. That is just a horizontal line at 4, at y equals 4, or f of x equals 4. So that's going to be 1, 2, 3, 4, like this. And then it says if x is less than 1. So 1 is right here. So I'm going to have an open circle right here, and it's everything less than, so everything right here. Now this one's a little different because what's happening at 2? Nothing. It's still a function. Every input has one output, but an input of 2 has, less than that, and it's fine because there's still no repeats. Okay, number 9, just a little hole in the graph there. Now we have 3 parts of our function. So x plus 1 is where we'll start, and the slope is 1. So it's up 1 over 1. The domain is that x is greater than 1. So here's 1, and it's going to be anything bigger than that. I'll do an open circle, and anything above that. Everything else I get to erase. Okay, on the next one, x is equal to 2. And x is equal to 2, f of x is equal to 2 everywhere in between -4 and 1. Okay, so now I get to take this into account. There's 1, and it's or equal to, so that means I'm going to have a closed circle here. And then at -4, it's an open circle. So I have an open circle and a closed circle, and I'm going to connect those 2 dots. Everywhere else I can erase. All right, and then the last one, -2x minus 13. There my y-intercept is -13. There we go, right down there at the bottom. And my slope is -2. Well, here it's going to be kind of hard to go down to, so I'm going to go instead up 2 and then to the left 1. Up 2 and to the left 1, 2 and to the left 1, and so on. Okay, so that helps me create my line, at least the part that's on the graph. And then it says this is true when x is less than or equal to -4. Here's -4, less than or equal to, so I'm going to have an open circle, and I want all the values to the left of 4. And this is actually going to create an increasing line, but it's okay because everything is still less than or equal to -4.